In this video, we're going to do the integral of the square root of x squared plus 1. So we know that tangent squared theta plus 1 is secant squared theta. So it makes sense to let x be tangent theta. Dx will be secant squared theta, d theta. So this integral will turn into the integral of the square root of secant squared theta, but that's just secant theta. And then secant squared theta again. So that will turn into secant cubed theta, d theta. So now let I be the integral of secant cubed theta. So we're going to do the I method. We're going to differentiate secant theta. We're going to integrate secant squared theta, which is tangent theta. The derivative of secant theta is secant theta, tangent theta, plus minus this term times this term. And this term is an integral. This two terms are integrals when multiplied together. So this will be secant theta, tangent theta. We have minus the integral of secant theta, tangent squared theta. Tangent squared theta is secant squared theta minus 1. So this turns into, I'm not going to write the first term, but that would be minus integral of secant cubed theta, d theta, and then plus negative 1 times secant theta is plus the integral of secant theta, d theta. Now this is I minus I, so we're going to add the I on the other side, so that would be 2I being equal to secant theta, tangent theta, and then we have plus the integral of secant theta, d theta is ln, absolute value of secant theta, plus tangent theta. So we're just going to include that. And now we have 2I equals this, so that means that I is 1/2 times these added together. Okay. So this will be 1/2, then secant theta, tangent theta, plus ln of secant theta, plus tangent theta. We're not going to add the plus c yet. So tangent theta is x over 1. So we're going to draw a right triangle. That would be theta. And now tangent theta is opposite over adjacent. So x will be opposite, which is here, and adjacent is here. We're going to complete the squares, or do the Pythagorean theorems. This will be the square root of x squared plus 1, which is actually in the original integral. It's the same thing, but usually it shows up. So this means that secant theta, that's usually, so cosine is adjacent over hypotenuse, so this will be hypotenuse over adjacent, but adjacent is 1. Hypotenuse is the square root of x squared plus 1. So now we have the integral of the square root of x squared plus 1 will be 1/2. Secant theta is the square root of x squared plus 1. Tangent theta is x. Now we have plus ln absolute value of x plus square root of x squared plus 1. And you might be able to simplify it more, but that is the end of the video. Hope you liked it.